Hello everyone, this is Mr. Swapnil Babusai Verwade, the faculty in Mechanical Engineering Department in Sharad Institute of Technology Polytechnic, Yadra, Ichalkaranji. Our institute has NBA accredited institute. In that we have accredited all 6 programs in first time itself in 2018. Next, we will move to the next one. This is teaching and examination scheme. In that teaching scheme, in a week, there are total 3 lectures and practical per batch will be for 2 hours. So we can say the total credit will be of 3 plus 2 is 5. Then examination scheme in our subject is for total 150 marks. From that, theory is for 100 marks, practical is for 50 marks. Then theory have again divided into two things, that is ESE and PA. ESE means end semester exam. In that we can see something like 70 star hash as some upper arrow, which means there is an online exam of that subject. You will have an online exam after finishing of your second unit test, okay, which will have some 60 questions. From that 50 questions for 1 mark, 10 questions will be for 2 marks. There is no negative marking, okay. Then second, we have PA, that is progressive assessment throughout the semester. It is for 30 marks. From that 30, it is divided into again two parts. 10 marks for micro project, 20 marks for your average of 2 unit tests. 10 marks for micro project will be the same micro project will be given by your faculty members at the start of the semester, and throughout the semester you will work on that and you prepare the project report, your diary, and you can submit it at the end of the semester to your faculty member, and faculty will evaluate it and give you the mark from 10, and the remaining 20 marks will be the average of the 2 unit test. As our subject is having online exam, so and both of the test or both of the unit tests will be a MCQ type, that is multiple choice question type question paper. Okay, so the first unit test will be on a paper, or we have the 20 MCQ questions, okay, and second unit test will be an online exam which is conducted by the MSBT. So you will have the thorough knowledge that how the online examination is all about, okay. So this total is the 100 marks, that is ESC for 70 mark online exam, PA for 30 marks, and it is total 100 marks, okay. Then we move to the practicals. In that also we have two things, that is ESC end semester exam for 25 marks and progressive assessment for 25 marks. In that ESC, there is something written like 25 at the rate, means it is have external practical examination, okay. And in progressive assessment we have again 25 marks, that is a term work which will be given you on the basis of your manual submission, how you perform in the practicals and how you attend your practicals, okay. So this is what about the examination scheme, okay. So the total subject is for 150 marks, theory for 100 marks, practical for 50 marks, okay. We will move to the next one. As we are the technical students, as our institute is NBA institute, or we are a technical student, we must know what are the outcomes of a subject, because we are going to go through the subject for 3.5 months. So we will know before the studying a subject, we must get what will be the outcomes. So in this, we have total 6 outcomes. First one is the identify the properties of materials. As we know, there are so many properties of materials, as like physical properties, mechanical properties, chemical properties, magnetic properties, and so on, okay. But as our subject concern, we will deal with the physical properties and mechanical properties. Physical properties are like density, color, dimension, and the mechanical properties are like the strength, toughness, stiffness, malleability, ductility, hardness, brittleness, then fatigue, creep, machinability, castability, forgeability, and formability, and so on, okay. So these are some properties, we will go through it, and after studying the first chapter you will know or you will identify the properties of materials. Second outcome, select relevant ferrous materials for mechanical components. Now there are so many materials in the world, but as per our subject concern, we will limit our materials up to ferrous materials, non-ferrous materials, non-metallic materials, and some advanced materials which is related to industries. Okay, so what is meant by ferrous material? Those materials which have iron as a base metal or principal metal, or those materials which have iron as a higher composition. If I take an example of steel, steel is an alloy. It is alloy of iron plus carbon plus molybdenum plus silicon. Okay, in this the percentage of composition of iron is around 90 to 95%. So it is a base metal, it has composition. So those materials are called as ferrous materials, such like steel and cast iron. So after studying a second chapter, you will get or you can select relevant ferrous materials for mechanical components. Okay. Then third, select relevant cast iron for engineering applications. We have just four types of cast irons: white cast iron, grey cast iron, malleable cast iron, and ductile cast iron. Okay. So after studying this chapter, you will select relevant cast iron for the engineering applications. Next, fourth one, use non-ferrous metals for mechanical components. Again, there is a term like non-ferrous metals. Now, non-ferrous metal means, or the materials means, those materials which doesn't have iron as a base metal or iron as a principal metal, means they doesn't have any composition of iron, or they have the small composition of iron. Okay. So after studying this chapter, you will use non-ferrous metals for mechanical components. Fifth one, suggest relevant advanced materials for mechanical components. In this, we will study the polymers, or you can say the plastics, the rubbers, then nanomaterials, the composites, and as we know, the polymer, the plastic is again divided into two types: thermosetting plastic and thermoplastic. Okay. So after studying this chapter, you can suggest relevant advanced materials for mechanical components. Then the most important topic in our syllabus, that is select relevant heat treatment processes. As you know, we can't get a pure metal as it is from the earth crust. It may have some softness, it may have some high hardness, so to change its property. To change the property of material, we use the heat treatment process. Okay. So after seeing the sixth chapter, or after studying the sixth chapter, you will able to select a relevant heat treatment process for any material. Okay. We will move to the next one. So we can see just the names of the topics that we will cover in the semester. Okay. So the first chapter is the basics of engineering materials. Second chapter is steel and its alloys. Third chapter is cast iron. Fourth chapter is about non-ferrous metals and its alloys. Fifth chapter is non-metallic and advanced materials. Sixth chapter is heat treatment processes. So these are the six chapters we are going to study in this semester. Okay. So now we will go through one by one what the point it covers, and we can see it. Okay. So the first chapter, basics of engineering materials. In this, the first point is classification of material. As we know, there are so many types of materials. We can classify them on the basis of their composition of carbon, on the basis of their properties, on the basis of their application. So as we know, the classification of material, in that we broadly classify the materials into crystalline material and amorphous material. Then again we classify into metals, non-metallic materials, some composites, some advanced materials. Okay, we will go through it thoroughly when we study the actual classification of material. Okay. Next, crystal structure, unit cell, and space lattice. In this, crystal structure is nothing but it is a three-dimensional arrangement of atoms in a space. In that we have some four types like simple cubic structure, body-centered cubic structure, face-centered cubic structure, and hexagonal close-packed structure. Then we have the microstructure, types of microscopes. Then we will have point like sample preparation of material. Then we have properties of materials. As I said earlier, there are so many properties of materials. In that, we are just going to concern with the physical properties and the mechanical properties. Okay. So in the mechanical properties, we have strength, toughness, stiffness, malleability, ductility, then hardness, brittleness, fatigue, creep, machinability, formability, forgeability, and castability. In physical properties, we have density, then color, then dimension, porosity. Okay. Next, we have the hardness testing procedures or the hardness testing machines. In our lab, we have two machines. First one is a Brinell hardness tester and second one is a Rockwell hardness tester. In Brinell hardness tester, we have the range from 250 kgf to 3000 kgf, and in Rockwell hardness tester, we have the load from 60 kgf to 150 kgf, or it have three scales like scale A for 60 kgf, scale B for 100 kgf, and scale C for 150 kgf load. This is what about the first chapter. We will move to the next one. In this we will see just what the classification of engineering materials. Okay, so we can broadly classify engineering materials into the metals and the non-metals. The metals are again classified into ferrous and non-ferrous. Ferrous means those contain the iron as a base metal, and non-ferrous means those doesn't contain iron are the non-ferrous materials. Okay, the ferrous materials are again classified into wrought iron, carbon steels, alloy steels, and cast irons. The non-ferrous ions or the non-ferrous materials are classified into aluminium, copper, lead, silver, tin, and zinc, etc. The non-metals are classified into two types, polymers and ceramics. Polymers are classified into thermosetting polymers and thermoplastic. Thermosetting polymers are again classified into phenol form, aldehyde, that is also called the bakelite, the polyester, and epoxy resins. And thermoplastic are classified as a PVC, that is polyvinyl chloride, polythene, acrylic, and resins. Then ceramics. Ceramics are classified into refractories, abrasives, the glass, cement, and concrete. Okay, so this is a broad classification of material. We will go through it one by one. Okay, so we will move to the next one. So this is second chapter, that is steel and its alloys. In that, the first point is concept of phase, pure metal, and alloy. The phase means something, as we all know, there are three types of phases: solid phase, liquid phase, and gaseous phase. Then pure metal, it is a metal which have the valency 1, 2, or 3. Just now we can take an example of aluminum and magnesium. Then alloy. Alloy is a combination of two or more metals or the non-metals in which one should be a metal. Then we have solid solutions. Solid solution is nothing but a combination of solute and solvent. Okay. So what is meant by solute and solvent? If I take an example of, let's take an example that if I add a 1 liter of water in 100 gram of sugar, okay, so we can mix the both the things, 1 liter of water and 100 gram of sugar, we can get some solution. Okay, so the 1 liter water have the high composition and 100 gram sugar will be have the low composition. So the which one have the high composition is solvent and which one have the low composition is solute. So I can say solute plus solvent will give you the solution. Okay, but that is a liquid solution. What we form after mixing the water and sugar, we will form the liquid solution. Okay, then in solid solution we just replace the solute and solvents in a solid state. Okay, we will see it afterwards. Okay, the next, the heart of the metallurgy, that is iron carbon equilibrium diagram. At diploma level we have just 3 points from that: the phases, the critical temperatures, and the reactions. In total we have 7 phases, that is alpha ferrite, delta ferrite, austenite, cementite, lead-borite, pearlite, and liquid iron. And next we have 5 critical temperatures, that is A0, A1, A2, A3, and ACM. And then we have 3 reactions, or you can say 3 transformations. They are like eutectic transformation, eutectoid transformation, and peri-eutectic transformation. Okay. Next point is plain carbon steel. This is again classified into 3 types: low carbon steel, medium carbon steel and high carbon steel. Low carbon steel having the carbon percentage from 0 to 0.3%. Medium carbon steel will have the carbon from 0.3 to 0.6%, and high carbon steel will have carbon from 0.6 to 1.5%. Okay. The next we have alloy steel. Alloy steel means nothing but it is an alloy to have, we made a alloy to get some good properties. In that also we have some types, just like hot work tool steel, cold work tool steel, high carbon high chromium steel, and oil hardening non shrinkable steel, that is OHNS. Then we have tool steel, that is also called as a high speed steel, or we can call it as a high speed tool steel also. Okay. The next we will have the stainless steel, which is never get corrode in any environmental condition due to the presence of chromium in it. Okay. The next is a spring steel. Spring steel is some steel which is used to make these springs to have a good stiffness in it. Then we have the specification of steels. This means we can specify the steel on the basis of their composition, their properties and its applications. And last point in this will be the general applications. In this, applications from the industry, applications from the automobile sector, application from the some household appliances. If we see it from the automobile sector, we will have some applications like the axles, cylinders, camshaft, crankshaft, piston and gears. Okay, so this is what about the second chapter. We will move to the next one, that is cast iron. In this we have four types, as I said earlier: white cast iron, grey cast iron, nodular cast iron and malleable cast iron. In this first, white cast iron, it shows the white color when it get fractured due to presence of cementite. And same way, the grey cast iron, when it get fractured, it shows the grey color because it have the presence of graphite in it. Okay. Then the next point we have, that is specification of cast iron. We again specify the cast iron on the basis of same, that is properties, application and their compositions. Then here also we have go through the engineering applications and designation of steel and cast iron. Designation means we are going to name each and every steel on the basis of their carbon composition, on the basis of their alloying elements, on the basis of their other different properties and applications. Okay. So we will move to the next one. This is fourth chapter, that is non-ferrous metals and alloys. In this, the first one we have copper and its alloys like brass and bronze. Brass is nothing but an alloy of copper and zinc, and bronze is an alloy of copper and tin. Next we have aluminium and its alloys. In this we have Y alloy, indalium and duralium. Okay, as this is chapter is related to non-ferrous metals and its alloys, so this all these alloys, Y alloy, indalium, duralium, brass, bronze, or we can say Muntz metal, or we can say naval brass, all these have iron composition but in a very less amount, so they are non-ferrous metals and they are alloys. Okay. The next point is of about the bearing materials. The bearing materials are those materials which can used for making the bearings. They are like Babbitt materials, that is tin based material, white Babbitt materials. Okay. Next we will move to the move to the next chapter, that is fifth chapter, non-metallic and advanced materials. In this we are going to see the first polymers. Polymers means, poly means many, mers means the units, that is many units we can say. Okay. In that we have 3 points of the 3 types, that is thermosetting plastic and thermoplastic. Then rubbers. In this, thermosetting plastic means those plastics which are once softened and hardened, they again can't get softened. Those are generally hard plastics. They doesn't have any scrap value because they again doesn't get soft. Okay. Then thermoplastic means those plastic which can be again and again we can soften it, again and again we can hard it as per our requirements. So it have good scrap value but they are somewhat the softer ones. Okay. Then we have the rubbers. Rubbers can be used for our balloons and everything. Okay. Then for washer purpose. Then we have the ceramics. Then we have composite materials. Composite materials are again classified into two types, that is reinforced composite and layered composites. Layered composites, or we can say it as a laminar composite. The best example is the plywood. It is an example of laminar composites. And for the reinforced composites, we have best example as a RCC, that is reinforced concrete cement, in which we mixed some things. So that is reinforced composites. Okay. And the last one is advanced engineering materials. In this, we have the materials like nanomaterials. We will study it. Okay. So we will move to the next one. This is the most important chapter in your syllabus, that is heat treatment process. As I said earlier, we can't extract as we want from the earth crust. As I want, if I want the material with a good hardness, good toughness, good fatigue, everything I want good, it is not possible. Okay, so when I extract from the earth crust, I get something which have the low softness, which have the huge hardness. Okay, so I have to change its properties somewhere. So to change the properties of material, I use the heat treatment processes. It includes just three steps. First, heating a material. Second, hold the material at optimum temperature. And third, cool the material. Okay, in this, we will heat the material as per our requirement, up to some temperature. Then we will hold the material as per the temperature range, as per the size of the component, as per the composition of material. Okay, then we will cool the material in any cooling media. We can cool the material in furnace, we can cool the material in air, we can cool the material in water also. Then these three types, first three types, that is annealing process, normalizing process and hardening process, are divided on the basis of their cooling media. If we cool the material in furnace, it is a annealing process. If we cool the material in air, it is normalizing process. If we cool the material in water, it is hardening process. Okay. So the next process will be the tempering process. It is a process which is always followed by after the hardening process. Because in hardening process, we can't control the cooling rate, because the time for cooling is very slow, very less. As it is in seconds, we can't control it. So sometimes the hardness of material is so much increased than what we want. So again we have to go through the tempering process to decrease the hardness of the material. So we again heat the hardened steel to some temperature, then hold the steel at optimum temperature for some time to get homogeneous structure, and then we again cool it in a air to get optimum hardness as per our requirement. Okay. Next, we have case hardening methods like carburizing, nitriding and cyaniding. In this, as a material, it has two things. It has a core and it has a case. Case means the upper part of the material. Core means inner part of the material. This is case hardening methods, means we will just harden the outer surface of the material. In carburizing, we add carbon on the surface of the material so that their hardness can get increased. In nitriding, we add nitrogen on the surface of material so that its hardness get increase. In cyaniding, we will add carbon plus nitrogen on the surface of material to increase the hardness. Okay. And last, we have heat treatment furnaces. In heat treatment furnaces, we have so many furnaces. In lab, we have muffle furnace or box type furnace, in which we can attain the temperature up to 1200 degree Celsius. We can heat anything in it. Just if I convert the phase from alpha ferrite to austenite, okay, so we can heat it in the muffle furnace. Okay, so these are the 6 chapters. We will go through it as the semester proceeds. Okay, next. We will now start with the single point or the first point of the syllabus, that is what is a material science. Okay, So the material science is an interdisciplinary field involving the properties of materials and its applications to various areas of science and engineering. As we see in the diagram also, we can see at the center point we are written as a material science, and outside circles we have like physics, chemistry, engineering design and crystallography. As I said, material science is an interdisciplinary field, means it has some basic things, or we take some basic things from physics, from chemistry, from crystallography, and we can use its all applications in engineering design. So it is an interdisciplinary field. Okay, we will move to the next one. Metallurgy. What is metallurgy? It is the science of extraction of metals from their naturally occurring sources is known as metallurgy. Means extraction of the ore. Ore is nothing but a naturally occurring source which have the metal in it. Okay. As we know, all the metals, non-metals are found in the earth crust. So we have to extract it. That extraction of the ore or the metals from the naturally occurring source from the earth is called metallurgy. And we can't get a pure metal in the earth crust. It might be with some impurities in there, or with there it in a fusible form. So to separate out that waste material or that impurity from the pure metal or the material, we use the smelting process. Smelting process means it is the heating of metal with the coke and limestone, so that we can separate out the waste material from the metal. Then what the waste material is get separated from the metal, or we can say it is as earth impurity, it is called as a gangue or matrix. So at the end I can say that ore is nothing but metal plus gangue. So in whole sense we can say that metallurgy is nothing but a science of extraction of metals from their naturally occurring source. It is a metallurgy. Ore is nothing but it is a naturally occurring source which have metal in it. Smelting process is to use to separate the metals and the waste material, and gangue means it is a waste material which is in fusible form with the metal. Okay, so we'll move to the next one. In general, the material is anything made of a matter. It may be a finished product or unprocessed raw material. Just like examples, the metals, non-metals, plastics, the glass, ceramics, rubbers, timber, alloys, etc. Okay. In all these materials, we have one thing common, that is atoms. As we have studied it in chemistry in first semester, that atom is the smallest indivisible particle of an element. It is smallest indivisible particle of an element. It consists of something called nucleus, or we can say nuclei, and it has some outer cells. In nuclei, it has protons and neutrons. In outer cell, it have the electrons in it. In nuclei, we have proton with a positive charge, the neutron with a no charge, and in outer cells we have electrons. In this also the cells are named as like K, L, M, N. In first cell we put 2 electrons. In second cell we put 8 electrons. In third cell we put 18 electrons. In fourth cell we put 32 electrons. How it is defined? That it has some formula, that is 2n square. That n means the number of cell. If we put n as a 1, we get 2. If we put n as a 2, we get 8. If we put n as a 3, we get 18. Such that 32. Okay. So depend on that formula, we can put the electrons in the outer cells. Okay. So we'll move to the next one. So we will start with the fresh point, that is types of materials. We have 2 types, that is crystalline material and amorphous material. Okay, move to the next one. See, crystalline materials means those materials which have regular or systematic arrangement of atoms. As you can see in the figure, those red balls are called as the atoms. Okay, as in the first we have the crystalline structure. see those atoms are placed in vertical line and in horizontal line, or you can see the column wise or row wise in a well systematic manner. Okay, as per our their placing, we can say they are systematically placed or they regularly placed. So they are called as a crystalline material, and they are the harder ones, just like iron, diamond, the ice cubes, and the salt. As an example, I can see that we have stated that all the metals are the crystalline materials, many ceramics which are harder ones, and some polymers also which are the harder plastics. Okay, so if we place the atom in a regular manner, we place the atom in systematic manner, then those materials will be the crystalline material. Okay, so we will move to the next one, that is amorphous material. In this we can see in the diagram itself, the placement of atom are randomly placed. There is no any such configuration, no any rows, no any columns, no any horizontal way, no any vertical way. They are placed randomly. So, in definition, those materials which have irregular or unsystematic arrangement of atoms is called amorphous material. Okay, as they are placed randomly, they are softer ones, as like a plastics, rubbers, wood, wax, and the glass. Okay, you get the idea? Crystalline means regular and systematic arrangement of atoms. They are the harder ones, and amorphous means the irregular and unsystematic arrangement of atoms. They are generally softer ones like plastic, rubbers, and wood. Okay, so we'll move to the next one. As in the as I said earlier, we have seen the two-dimensional view of the crystalline structure and amorphous structure. The crystalline have a systematic arrangement, amorphous will have the random arrangement or unsystematic arrangement. In below, we will see the three-dimensional view. In this, you can clearly see the crystalline arrangement is regularly placed. They are in a rows, they are in a columns, they are well mannered systematic arrangement. In amorphous, we can't see there is any systematicness. They are arranged as a randomly. So you can get those materials which are systematically placed, those are the harder ones, those are the crystalline material. Those metals or those materials which have the structure like unsystematic or irregularly placed, those are called the amorphous materials, or those are the softer ones. Okay, so we will move to the next. So again, these are the examples of crystalline material. Crystalline means those are systematically placed, so they are harder ones. In this first we have table salt. In next we have the diamond, the hardest material. And in third we have ice cubes. Okay, so these are the examples of crystalline material. Next we have the examples of amorphous material. In first we have see the rubbers, or we can say the balloons. In second we have plastics. In third we see the girl carrying a cotton candy. This is an example of amorphous material, which are somewhat softer ones because their atoms are randomly placed. Okay, their bonds are not so stronger. Okay. Next, the metals are classified again as a ferrous metals and non-ferrous metals. As I said earlier also, ferrous metals means those metals which have iron as a base metal or principal metal or have a high composition of iron. Just an example of steel. Steel is an alloy of iron and carbon. That iron varies from 90 to 95%, carbon varies from 0 to 2%, and others are like molybdenum, sulfur, phosphorus, nickel. Okay, so this is steel. And cast iron is also a alloy of iron and carbon, in which iron varies from 90 to 96% and carbon varies from 2 to 6%. We get the cast iron alloy. Okay, so these are the two best examples of the ferrous metals because they have iron as a base metal or principal metal. Okay, so the next one, non-ferrous metals, those metals which doesn't have iron as a base metal, or they doesn't have iron, or they have only less composition of iron in it, they are called non-ferrous metals. In this we have aluminium and its alloys. As we seen earlier, there are some alloys like bi-alloy, indalium and duralumin. They doesn't have any iron composition. Second, we have copper. Their alloys are like brass and the bronze. Brass is made up of copper and zinc. Bronze is made up of copper and tin. They also doesn't have any iron constituents. Okay. Next, zinc and their alloys. Third, magnesium and their alloys. So these are the examples of non-ferrous metals. Means the ferrous metals, those which have iron as a base metal. Examples are steel and cast iron. Non-ferrous metals means those which doesn't have iron as a base metal. Examples are like aluminum and its alloys, copper and its alloys, zinc and its alloys, magnesium and its alloys. Okay. So we'll move to the next one. In the last, we will see just a broad classification of material and we will end this video. Generally, the engineering materials are broadly classified into metals and the non-metals. Here in this diagram, we are classified into the metals and the non-metals are separately classified into plastics, ceramics and the composites. In this also, the metals are classified into ferrous and non-ferrous. Ferrous again, iron as a content. Their examples are steel, stainless steel, tool steel and die steel, and same with the cast iron, and again that is grey cast iron, white cast iron and so on. The non-ferrous, which doesn't have the iron content, they are like aluminum and their alloys, copper and their alloys, titanium and their alloys, tungsten and their alloys and others. Next, the non-metals are classified into three things like plastics, ceramics and composites. The plastics are again divided into three things, that is thermosetting plastic, thermoplastic, or you can say thermosets, and the elastomers. The thermoplastics are again classified into acrylics, then ABS, that is acrylonitrile butadiene styrene, then nylons, then polyethylenes, then PVC, that is polyvinyl chloride and others. Thermosets are classified into epoxies, phenols, polyamides and others. And the elastomers, that is nothing but a rubber, is classified into the rubbers, silicones and polyurethanes. Next we have ceramics. Ceramics are classified into oxides, nitrides, the carbides, the glasses and the ceramics, the graphite and the diamond. All these are the harder materials because ceramics is from the crystalline type of material. Okay, then the last we have composites. As I said earlier, we have two types, that is reinforced composites, which is the example of RCC, that is reinforced concrete cement, and second one is a metal matrix or laminar composites, which are the best example is a plywood. Okay, so this is the introductory part to our first video. Okay, thank you one and all.